Hi, we're now looking at a teaching video on the applications of integration. In particular, the equation of a curve. There are equivalent terms for dy over dx. So far, we have looked at gradient function of a tangent to a curve. But dy over dx is also the gradient function of a curve or derived function of first derivative. So if dy over dx is the first derivative, then the second derivative will have a symbol like this, d squared y over dx squared. So that is the second derivative. So if we look at integration, we can think of it as anti-differentiation. What it means by this term here, anti-differentiation, is the reverse process of differentiation. We can see here, this is the integration sign. Very much like a very stretched S. This is the integration of the second derivative with respect to x. If I integrate that function, then I will have the first derivative plus c. So if you differentiate with respect to x of dy over dx, then you will get d squared y over dx squared. Let me write it for us. If I just differentiate with respect to x of the first derivative, then I will get my second derivative. So that is differentiation. The reverse process will be integration. That's why you can see here, if I integrate this with respect to x, I'll get back what's in the square bracket, dy over dx. But I will also need to include a constant term because this is an indefinite integration. So looking at the first derivative, if I just integrate it, I should get the y function. So I will get y plus a constant. Instead of using the same symbol for the constant term, to avoid confusion, I will just give it a d. So let me over here show how the process is for the differentiation. So if I differentiate the y function, I'll get the first derivative, dy over dx. What I'm seeking to do over there is to integrate dy over dx, and I get my y. Again, let me stress this. This integral is an indefinite integral, and therefore I will have to include a constant term in my result. We are now looking at equation of a curve proper. You have seen the result we had before. If dy over dx is given, to find the equation of the curve, I would then have to involve indefinite integration. So y equals integration of the first derivative with respect to x. This is the result we had in the last slide. Of course, when you do that, you will have y plus c. So c is found from the, we're referring to this c, from the y-intercept of the curve. Let me just talk about this y-intercept. This is the y-intercept. So if I give you some example, let's say y equals x squared plus 2, then 2 is the y-intercept. What it means is, you can see, along the y-axis, the value of x is 0. So if I put the value of 0 into the equation, 0 squared here plus 2, I get a 2. What it means is the curve will have to cut through here. And at this point where x is 0 and the y value is 2. And for your information, the curve looks like this. It's a quadratic graph. You can see the curve cut through this point. So for this, c is found from the y-intercept of the curve. Or if you already know the intercept coordinates, then it will be the y-coordinates of this point. You can see the c is appearing here. Of course, in the event that you're not given the coordinates of the y-intercept, or you have no knowledge of what c is, that's why you're looking for the c, then you use any point that is on the curve. Supposing you know this point here, and this point is that you have 2, 6. Then you would use this information and plug x equals to 2 right into the expression there, and plug y equals to 6 right into it. So c can be evaluated by substituting the, I'm looking at this, the x coordinates and the y coordinates of a point xy of the curve into this form. Y equals indefinite integral of the first derivative with respect to x. So basically, we can find the value of c in 3 ways. 1, looking at the y-intercept. It can be from a curve like this, showing where the intercept is, or the point is already given to you, 0, c. So you just pick the y coordinate to be the value of c. Or in your integration, what you need to find the c then is to use the x coordinate and y coordinate of a known point on the curve. So this is how equation of a curve can be found basically from the first derivative and you integrate that, but take care of the constant term, because that is one of the results for the integration. So we have come to the end of this video segment. Review it as often as you can so that you're very familiar with the idea.